Good day, all. My name is Uchakalam Elechi Leonard, and I'm here to present the course project on IT 6244. We're going to be choosing the topic from the group 2, the dynamic routing, EIGPR, and EIGPR tuning and troubleshooting. So, the dynamic routing. What is dynamic routing? Dynamic routing is the process of selecting the best path a data a data package must follow through a network to reach a specific destination known as adaptive routing. Dynamic routing is a technique where a router obtains routing information without any administrator's assistance. The router adds the optimal path to a routing table and determines alternative routes if the primary path becomes less ideal or unavailable. Dynamic routing also refers to automated path planning method that complete routing operation through protocol and complex algorithms. So, how dynamic routing works? The routing sends and receives routing messages on the router interface. Routers share the messages and information with other routers using the same protocol. Routers exchange routing information to uncover data about remote network. In this way, when a network gets reconfigured, a router goes down. Each router's routing table can undergo proper adjustment. When a router discovers topology modification, the routing protocol advertises these changes to the other routers. Dynamic routing advantage. Exchange of routing information. With dynamic routing, routers can swap routing data when topology adjustment occurs. The information exchange empowers routers to learn about new networks automatically and discover substitute paths when connection to current network fails. Error reduction. Dynamic routing helps reduce the chances of committing error. That's because it runs path planning method mechanically. Scalability. In scalability, dynamic routing network can enlarge quickly with fewer administrative overhead costs. That's because network topology adjustment requires minimal effort. Dynamic routing advantages. Public rectification. Dynamic routing can correct problems in the network and keep functioning when the network breaks down or the configuration fails. Adaptability. Dynamic routing adaptability relates closely to its scalability, where the network grows or fails. The network can learn about the change and adjust accordingly. It can also be rerouted in response to the modification without any manual intervention. That's for dynamic routing advantage. Then for dynamic routing limitations. Com- Complexity. Dynamic routing is complex to implement initially. When a router adapts to network change, it must always remove unwanted information from the routing table. This kind of scenario increases the complexity in the routing protocol. Resources. Dynamically routed network requires additional resources, e.g., CPU, memory, RAM, and link bandwidth. To calculate dynamic route, hold routing tables, and perform other tasks. Dynamic routing also requires knowledge of supplementary command communication. Some and all machines in a network might not speak any dynamic routing protocol or a common protocol. Then for the other one, um, dynamic routing limitation, bandwidth shortage. Dynamic routers consistently communicate with one another using a dynamic routing protocol to share network topology information. This continuous exchange requires more bandwidth. The messages can also cause bandwidth shortage when communicate with low-speed link, especially in expansive and unstable network. Security. Dynamic routers pose network security hazard because of the broadcasting and multicasting update. Routers consistently exchange and advertise or send out complete routing table and critical information, e.g., IP address or two routers across the network. Securing dynamic route requires added configuration settings such as routing protocol, authentication and passive interface. That's for dynamic routing limitations. Then for examples of dynamic routing protocol that are commonly used in computer network OSPF, Open Short Path First. OSPF is a link state routing protocol that is used in large-scale network. It determines the shortest path between the source and the destination by considering several factors such as network topology, link cost, and bandwidth. BGP, Border Gateway Protocol. BGP is an inter-domain routing protocol used by ISPs to exchange routing information between their network. It uses a path vector algorithm to select the best path for a package to reach its destination. RIP, Routing Information Protocol. RIP is a distance vector routing protocol that is commonly used in a small medium-sized network. It calculates the shortest path based on the number of the holes between the source and the destination. That's for examples of dynamic routing protocol that are commonly used in computer networks. So we'll go over to the last one. The examples of dynamic routing protocol that are commonly used in computer networks. EIGPR, Enhanced Interior Gateway Routing Protocol. EIGPR is a hybrid routing protocol that combines the feature of both distance, vector, and link state protocol. It is used in large-scale network and is known for its fast convergence time. ISIS, Intermediate System to Intermediate System. ISIS is a routing protocol designed to move information effectively within a computer network. A group of physical connected computers and similar devices. It accomplishes this by determining the best route for data through a package switching network. Then here is the role of dynamic routing protocol. An example: dynamic routing protocol, exchange of routing information between routers, dynamically learn information about remote networks, determines the best path to each network, automatically learn about new networks, automatically finds alternative path if needed, link failure in current path. Then we go over to the EIGP presentation. What is EIGPR? You see, okay, here. EIGPR, Enhanced Interior Gateway Routing Protocol, or EIGPR, automates the routing decision and configuration in computer networking. Cisco designed the protocol and is available only on Cisco routers. Minimum bandwidth is used from the source to the destination, and the delay is measured using metrics of the network. This is an advanced protocol to measure the distance and use both link servicing and distance routing. Hence, it is called a hybrid protocol. It transaction well with IPv6 and has the support of IPv4 as well. This is a classless routing technique. Two routers are connected and the network is shared in the EGP. So here's the shared in the AGP. Enhanced interior gateway protocol is an advanced distance vector routing protocol based on principles of the interior gateway routing protocol. It has a unique characteristic that improves the operational ability and fast covering rate. It can determine the shortest path distance vector, and it works on principle of the interior gateway routing protocol. A classless routing protocol, it uses metrics like bandwidth and load and delays to calculate the shortest optimal network route. It is a technologically and more advanced distance vector routing protocol to exchange information using EIGPR. First and foremost, the routers need to become neighbors to the EIGPR. Then the EIGPR uses the multicast address to share the information between them. Fundamentals of EIGPR. Enhanced Interior Gateway Routing Protocol is a dynamic routing protocol used for routers, decisions, and configuration. EIGPR only sends incremental updates, which is short, reduces the workload of routers and the amount of information transmitted. EIGPR is a classic hybrid protocol that supports classless routing. It supports automatic and manual summarization on an EIGPR enabled surface. Its MD5 authentication on routers running EIGPR also has a maximum hoop count close to 255. EIGPR performs load balancing over the equal cost path and unequal cost path. Go down to the next one. Neighbor table. The neighbor table consists information about routers and neighborship relationship with those who have been established. Command to list router information show IP EIGPR neighbors. The neighbor table has a field like age, handle, address, interface, hold time, and upper time, smooth round trip time, retransmission timeout, queue count, and sequence number. Examples of neighbor table. Time since the neighbor is added to the neighbor table, retransmission timeout, sequence timeout, neighbor IPv4 address, local interface receiving EGPR hello package, time remaining, and so forth and so on. Queue count, smooth, and trip type timer. So topology table. The topology table holds information about all the paths to networks understood by EIGPR routers. Command to list routers information show IP EIGRP topology. The topology table holds the following field: passive, feasible distance, advertised distance, and feasible distance. Examples of topology table. Here the passive and active destination network, number of successors and number of successors. Routing table. The routing table stores the routes which are currently active in sending package to the network. It stores the optimal routers for the destination from the sender. Command to delete router information show IPv6 router. The routing table holds the following fields: D90/5673 via 1.0.0.2 gigabyte Ethernet/1. Here is an example of the routing table. Then here are the packet types. Hello, it determines the neighbor's router and also serves as a keep alive mechanism between the routers. If router S is connected with router Y and the router S is not receiving the hello packet from the router Y, then it assumes that router Y is not reachable and the network is down. Updates are to send the information about the router to its neighbor when a new router is found. The update package sends the neighbor to build up the topology table. Move to the next one. Still under packet types. Query. Queries are used specifically for requesting route information. They act as multipath until they send information, receive queries as response. It sends the queries only when the destination state is active. Reply package responds to a query that indicates the originator router that it does not need to go into an active state as reliable successor for the destination network. Replies are sent with destination go into an active state for the reply package and acknowledgement is sent. Packet type ACK acknowledgement packet will be sent to enhance the interior gateway routing protocol query update and reply package. It is shared with uncast address. It is shared with uncast address and also acknowledgement not sent to the hello package. Now we go over to the network, the EGPR turning and troubleshooting discussion. Component of troubleshooting EGPR component diagonalizing EGPR. So we go, that's the picture. Network topology. Serial interface and their bandwidth may not reflect the more common types of the connection found in the networks today. The bandwidth of the serial links is used in the calculation of the routing protocol metrics and the process of best path selection. The bandwidth command will be used to modify the default serial bandwidth of 1.44 kbs kilobyte. The next one. This example of network topology EIGPR for IPv4 topology. The next one. Starting IPv4 interface and IEGPR configuration. EIGPR automatic summarization. Route summarization is one of the most common methods of turning EIGPRP. Route summarization works by grouping multiple networks together and advertising them as one longer network or summarized route. EIGPR can be enabled to perform automatic summarization at classic full boundaries. EIGPR automatically recognize subnet as a single Class A, Class B, or Class C network and creates only one entry in the routing table for the summary route. EIGPR automatic summarization. For routers to find the best route for each individual subnet, subnet information must be sent in the examples above. Automatic summarization should be disabled so the subnet information will be sent. Explanation about EIGPR automatic summarization. Router 1 and Router 2 are both configured using EIGPR for IPv4 with automatic summarization. Arrow 1 has 3 subnets in its routing table: 1.172.16.1.0/24, 172.16.2.0, 17.0/24, 172.16.3.0/24. These subnets are all considered part of a larger class 172.16.0.0./16. When arrow1 sends its routing table to arrow2, it will send 17.this and summarize the work. Automatic summarization. Automatic summarization is disabled by default for EIGPR or IPv4, beginning with Cisco iOS release 15.01 MB and 12.2 33. Use the show IP protocol command to determine if the EIGPR automatic summarization is disabled. To enable automatic summarization for EIGPR, use the auto summary command in router configuration mode as shown in the figure to the left. Use the command no auto summary to disable automatic summarization. Configuring EIGP automatic summarization. Verifying automatic summarization. Show IP protocols. Output from the show IP protocols command on arrow1 shows that automatic summarization is enabled. Output also indicates the networks that are summarized on which interface. Here's verifying the show output protocol. Summary route. The scenario in this figure walks you through an example on how automatic summarization could also cause a routing loop to occur. There's the summary route. Example of a routing loop. Well, thank you all for watching and listening to me. My name is Leonard.